grades are better than I. Okay, here's what you do. Take whatever your combined grade was, okay? Current grade. Multiply it by 0.7, then add 0.3. That will be your grade. For example, if you had a 70, 7 times 0.7 equals 49. You add a 15, add a 30 to that, that'll put you at 79. Fair enough? Okay. You still need to study like the dickens for the retest, but you know, I sent you an email, right, with your current grade, so everybody knows what you got. Multiply it by 0.7 and add 30 to it. Just trying to thank you. Okay. Y'all ready? Here we go. All right, let's pray, and we'll get going. Heavenly Father, thank you for today. Thank you for the world that you've made and how everything has just been uniquely and perfectly fit together to make life possible and to make it thrive. Thank you for how you put the breath of life into us, Lord. It's living creatures. Lord, thank you for the minds that you've given us to be able to understand the world around us and to see something of your divine plan and grandeur and glory in all of creation. Just have an understanding of that today as we look at the seed-bearing plants. We praise you for this in Jesus' name. Amen. All right, well, we've talked about plants a fair amount to this point. We were starting to look at some of the vascular systems last time. You guys certainly know what xylem and phloem is. We talked about something called a vascular cambium, and we talked about something called a meristem, in particular an apical meristem, right? Where would I find an apical meristem?
Between the xylem and the phloem.
No.
No?
No, that's a vascular cambium.
Oh.
An apical meristem I will find at the apex, at the tip of some kind of a root or a shoot. Okay? It's indeterminate cells. They can become anything. They can become xylem, they can become phloem, they can become cambium, they can become bark, they can become anything. Okay? Which is great. It's analogous to our stem cells. what that essentially means is that all the genes in them are open, available to be turned from DNA into RNA into protein. Whereas later on, the reason that cells are differentiated so much is certain genes are shut off. So they cannot, it's called epigenetics, they cannot be transcribed and translated. And so this is useful, right? You don't want your body making teeth on your arm, that would be gross. And you don't want, pubic hair growing in your mouth, and that's just weird stuff. And you don't want the cells in your mouth making hydrochloric acid. And the reason that the cells do different things is because genes are either turned on or off. Those are highly differentiated, specialized cells. Germ cells, meristem cells are not. They can become anything. They'll later on be turned on or off, okay? So that's the idea of a meristem. The other thing that we talked about was a cambium. A cambium is basically a ring of cells that, to the inside, what do they produce? Okay, so here's my vascular cambium. What do they make to the inside? Huh? Xylem. What do they make to the outside? Phloem. And so we're constantly growing like, if that's the center of the tree, we're constantly kind of growing like this. The cambium's getting pushed further and further out by the cells that it just made, but it's also making more cells, pushing them out this way. This is literally how a tree grows and gets bigger and wider year by year by year. You have these rings, one layer at a time, right? Okay. Actually, it was really neat. We just cut down 4 trees at my house, and because I was thinking about all this, I'm showing my boy, like, look at this, and here's the xylem, here's the phloem, here's the vascular cam, and he's 7, he's like, I thought it was neat. So, because you literally could see it. Okay, so those are just some important things with your cells and your vascular plants. We talked about gymnosperms and we talked about angiosperms. Gymnosperms. What do gymnosperms and angiosperms have in common? Seeds. Seeds. They're vascular, right? Okay. What's different about a gymnosperm and angiosperm?
Angiosperms have fruits to protect the seed.
Angiosperms have fruits. What gives rise to a fruit? Flower does. And what happens with a gymnosperm? No flowers, right? In fact, the very name gymnosperm means not no, naked. Naked seeds. And angiosperm means? Flower seeds. Very good. Okay. Gotta know that stuff. So here we are, we've got our seed plants, right? You got gymnosperms. You got angiosperms. The different phyla of gymnosperms and angiosperms, you don't have to know them all. Most of them, there's just like really almost 1 or 2 species that even exist in them. For example, ginkgo phyta. I don't know if this is as popular anymore. It used to be. It used to be that everybody would go buy these pills called ginkgo biloba. Have you ever heard of that? No? Okay. It was a pill that extracted something from the ginkgo plant, and I guess it was supposed to help you with your life. I don't know. Ginkgos, there's only one. Ginkgo phyta, the only extant. Oh, let me finish that. I'm going to teach you 2 vocabulary words that are homonyms. You got to know them, okay? One of them you know. You know the word extinct. What does that mean? No longer living. And extant then is the opposite of that. It means living, present, right? So there are, if we go and look at records, there's every reason to think that there were other extinct members of Ginkgo phyta but they're gone. There's only one that's extinct, okay? Extinct and extant are two words you must know going forward, okay? Now, write them up here. You must know these. You know the one, you gotta know the other, okay? It helps that they sound alike, so you can think, oh, it just means the exact opposite, okay? So one extant member of the phylum Ginkgophyta. These things are cool. They're beautiful. They have some of those beautiful leaves you'll ever see in your life. It kind of looks like a whale's. Or like a fan. Their leaves literally look like this. They're so beautiful, so cool. People like these. I believe they come in male and female. They don't, like the trees are, either make sperm or they make eggs. They don't make both, okay? People like to plant the male trees, or have the male trees and not the female trees, because the female trees produce this seed pod type of thing, and it smells like rotten butter. You ever smelled like rotten butter or rotten? It just stinks. It just smells putrid and makes you kind of want to vomit a little bit. And so these things stink, and people don't want them. But the males don't. The males just have the really pretty leaves. And they're gorgeous. And these trees are huge. They're massive. They come from China. Not that you have to memorize that, but you know, it's a fun fact. Another one is Cycadophyta. I hate these. You've probably seen them. They look like a weird pine tree, palm tree kind of a thing. They've got these like, I can't draw this right. My best drawing on this is going to be awful. You know what a palm tree, you know, the fans look like on those, right? They kind of go out like this. Right? Okay, so this has like whorls of these. They just kind of go around. I really need to show you a picture of these, because you've seen them before. You just didn't know that you saw them. You didn't know what they were. The thing about these is these have like these little devil evil thorns on the end of them. They're spiky like all get out. If you ever just run into one of these, you'll know it. And it's just like jaguar claws or something, and they're evil. You don't ever want to run into one of these by accident, like bump into them or something. It will sting you. What's the whole thing about this is they make seeds, right? But they don't make seeds in a flower. They produce, here it is. They'll produce this stalky kind of a thing, and then they'll have like this weird thing up here that's going to have their seeds in it. I'm going to look this up real quick. This is worth, in fact, I'll look at both of them so you can see them. Well, I'm doing that real quick though. So Ginkgophyta, Cycadophyta, these are plants that you see very often. They're more ornamental. This one has some medicinal purposes. No one's raising this because they want to eat the seeds. No one's raising this because of anything other than they think it looks cool. Okay? But then there's this one. What are these? What's that word? Coniferophyta. Conifers. You've heard of that, haven't you? Hopefully. Conifers. Okay, maybe not. Look at the first part of this. What does that look like? It sounds like cone. These things have cones. Right, so these are your pine trees and your Douglas firs and all that kind of stuff, right? So these are cone bearers. They keep their seeds in cones. We drew the life cycle of one of these last class, right? You gotta know it. We'll review it here in just a second, okay? Pull ginkgo phyta first. Look at that. Look at that beautiful thing. Isn't that pretty?
We can't see.
You can't see it? How's you doing that? Come on, man. I'm gonna reset the whole thing. It's just not cooperating. I don't have a remote to tell it to select that. All I've got is this one button. Go. Do it. Yeah. Okay. You see that, right? You're not impressed. Okay. I believe this is a male version. If this is a male, what's this going to be producing?
Sperm.
Sperm, right? What are you looking at? Is this a gametophyte or a sporophyte? What does the sporophyte make?
Spores.
Spores. What does the spore produce? Let's go here. So, sporophyte. What's the opposite of a sporophyte? Huh? Gametophyte. What does a sporophyte make?
Spores.
Spores. What do spores produce?
Gametophyte.
Gametophyte. What does a gametophyte make?
Gametes.
Gametes.
Okay.
When the gametes, eggs and sperm hook up, what do they make?
Zygotes.
Zygotes. Good. And what does zygote grow into?
Sporophyte.
Sporophyte. So you are looking at a sporophyte. You're looking at a male sporophyte. It's going to produce, it's going to produce a male spore. That male spore is going to turn into a male gametophyte. That male gametophyte is going to make a male gamete, right? The male gametophyte basically is the pollen, okay? That yellow stuff that gets all over the hood of your car, or if you know, depending on where you live, if you drive by and the ponds suddenly look like this limey, greenish, weird color because the pollen's floating on top, that's the gametophyte. It's going to produce male gametes. It's going to produce sperm, okay? When we talked about the cones and all this, so you had a pine tree, right? It's making cones, right? Makes female cones and it makes male cones. The male cones are little teeny tiny things and the female cones are actually fairly large, aren't they?
Mm-hmm.
Okay. Okay, so that's the sporophyte. Inside of those male cones, you make your pollen, right? You got a male cone here, and it's going to make, inside of here, it's got the spore thing, and it's going to make pollen, which is going to be my gametophyte. Single dot of pollen, or if I were to look inside of a female cone, then inside of here, it's usually two on a single thing, on a blade. At any rate, it's got a megaspore mother cell that's going to give rise to female gametes. In a single kind of sperm idea here. Here inside of this, you're going to make an egg, right? This thing lands on pore and makes its way and it fertilizes this egg and it becomes a zygote, right? And that zygote is going to grow into a seed, which then will drop out and will grow into a plant. And quite literally in a conifer, a little seed attached to like a little blade. And what's neat about that is when these fall out of a tree, and I realize we live in Texas, and yeah, it's called the piney woods here, but you don't probably encounter a lot of pine trees. When I lived in Oregon, pine trees everywhere. And so if you were anywhere, even close to the right time of year, you would just see these little helicopter wing things just falling to the ground. And so if there was any kind of a wind, they would fall slowly and the wind would carry them away and maybe lift them up, and that helps with seed dispersal. So that, you know, because the reality is it's going to be very hard for a little seedling pine tree to grow up right underneath a big pine tree because it's not going to have all the light. You want to be able to disperse your seeds, and so the whole structure helps with that. Engineering God has put into everything is truly incredible. So, sporophyte, spore, right, makes the gametophyte, which is going to make the gametes. They fuse, makes a zygote, makes the seed, and off we go. Okay? All that is to say, what are you looking at here? What generation? Sporophyte, right? And this thing is going to make the gametophyte, which is going to make the gametes. Okay. Why are we looking at ginkgo biloba? What type of plants are they? Gymnosperms, naked seeds, right? They don't have fruits whatsoever. All right, the other one I said we wanted to look at was a Cycadophyta. You've seen this, haven't you? See, somebody's trying to sell you one right here. I guess it's not going to show that. On the tips of these little fronds, I mean, it's like a needle. They are painful. So this thing is ultimately going to produce seeds, right? Male and female, and they cross-pollinate and they do their thing. They're cool looking, but yeah, not my taste. All right, and then of course Coniferophyta. You don't even need a picture of that, do you? They're just cone bearers. These are pine trees and everything else that's like that. All right. Looks at the life cycle of this. They tell you about cycads, they tell you about ginkgophytes, they tell you about gonadophytes. I don't care that you know about gonadophytes. And then we go into angiosperms. So let's go into angiosperms. What do you already know about angiosperms? What do they have?
Fruit.
Yes. What makes the fruit?
Cactus.
You said cactus?
Cactus seed.
No, well, that's what they do, but what makes them? Okay, so I have little kids, right? And my kids struggle to know what's the difference between a fruit and a vegetable, right? What is the difference between a fruit and a vegetable? What do fruits have that vegetables don't?
Sure.
Huh?
Powers.
What?
Seeds.
Seeds. Fruits have seeds, right? Think about that. Fruits have seeds. So how did those seeds get there? Like this dogma that I teach them, almost like a chant, is flowers make fruit, fruit makes seeds, seeds make plants. Okay? Flowers make fruits. Fruits. Fruits make seeds. And seeds make plants. And then the whole thing rips and turns around next generation, right? Flowers make fruit, fruit makes seeds, seeds make plants, over and over and over and over again. This is, if it doesn't have a seed, it is not a fruit. It's some kind of a vegetable, okay? It doesn't mean that vegetables don't make flowers and vegetables, that's what's crazy, is vegetables make fruits. Like a carrot makes a fruit, but the carrot is not a fruit. The carrot's actually the root of that plant, right? Think about celery. Celery makes fruits, but celery is not a fruit. Celery is the stem. Broccoli. Broccoli makes fruits, but broccoli is not a fruit. The bottom portion of the broccoli is the stem, the top portion is the flower. You're eating it before it goes to seed. You wouldn't want it once it had seeds. We need all kinds of parts of different kinds of plants, right? We can eat the roots, we can eat the stems, we can eat the shoots, we can eat the flowers, we can eat the fruits, we can eat the seeds. When you eat a pecan, you're eating the seed, right? When you eat celery, you're eating the stalk, or eating the stem. When you eat a potato, you're eating part of the root system. When you eat a beet, you're eating a root. All right. Here we go. Things you must know. Start by drawing that. Next step. That's going to be too complicated. We'll do it again. I'll show you how to do it. If you, look, if you just want to go like this, that's fine. You want to do it right. Go over, do a little dip, bring it back. Go over, do a little dip, bring it back. Just like that. Nothing too complicated there. And then you just come out here and you connect. Now draw this. Maybe at least two of them. step. Now ready? Next step, draw one big petal. And draw another petal or two. Give just a little dash of the stem, and then draw these, and then give a real stem. Okay. This is what's referred to as a perfect flower, okay? A perfect flower would be able to pollinate itself. It's going to produce male and female spores, male and female gametes. It can if I can get what's happening here to here, I can make babies, okay? Imperfect flowers, imperfect plants have either male or female. Cherry trees. You can plant all the cherry trees you want. If all you ever plant are male or all you ever plant are female, you will never get cherries. You must have male and female, okay? They'll both produce flowers. They'll both be pink. They'll both be pretty. But you got to go look at the flowers. If all the flower has is this, it's female. If all the flower has is this, it's male. You need both, okay? Perfect flowers have both. So, let's talk about some anatomy here on the flower. You must know this, okay? I'm going to go ahead and I'm going to draw this part. This whole thing is called a pistil. It's called a pistil, okay? There are three parts of the pistil you must know, and they go in this order: stigma, style, ovary. Stigma, right here, is literally sticky. Very healthy. This is where we want our pollen to land, and when the pollen lands, we want the pollen to stick, because I've got to get my pollen from the stigma down the style to the ovaries. So the stigma is sticky. This is the style. And these are the ovaries. Inside of your ovaries, what's going on inside of the lady's ovaries? Where you're going to make the babies, right? The baby for them is the seed, right? You have to have an egg to make a baby. You have to have an egg to make a seed. The eggs are right here. These are the female gametes, right? So this is a pistil, stigma, style, ovary. You must label these, and you must tell me what they do. You don't have to tell me anything about what a style does. I guess you could say the style lifts up the stigma. I don't care about that. But you must tell me that the stigma is sticky so that the pollen will adhere to it. You must tell me that the ovaries house the eggs so that we can grow into a seed, right? Which part of this is going to become my fruit? The ovaries. Think about the seeds. Flowers make fruit, fruit makes seeds, right? So it's part of the flower, it's going to make this fruit, and it's going to have the seeds. You know the seeds are in the fruit, so the seeds have got to be in the flower also. This is the part that's going to become your fruit. Okay? So, pistil, stigma, style, ovary, you know what these parts are now. The next part is here. Okay? This is called the stamen. Something I have always found helpful when thinking about this. Well, what is it? What does it do? What, gender is it? Whatever. Stay what? Stay beast. Stay men. Stay men. I've always found that that helps. We know that that's the name of the male sex organ in a flower. Okay? Stamen. Stamen has two parts to it. It has an anther and a filament. You know what the word filament means, right? Like some long strand. So you know which part the filament is. And then here is the anther. What does the anther do? It makes pollen. Stamen is the whole thing is responsible for making the pollen. It's got two parts. The filament is going to lift it up from the base of that flower. That's important because how are most of these flowers going to ever get their pollen from stamen to pistil? Pardon? Possibly by wind or just by bumping, but usually what's happening this time of the year with all these flowers? What's out there with them?
Bees.
Bees and flies and wasps and hornets and all these things. They're coming. This thing is sticky, right? Typical, they're going to produce some kind of nectar in this area. When they do, and the flower's rooting around, they may have nectaries down in the flower even. As that thing's trying to get in and get the nectar, inevitably it bumps against this anther and gets pollen all over itself. And then when it goes to the next thing and it's doing its thing, some of that pollen bumps off on the stigma and it sticks. Okay? Now, so it's important that this thing be elevated so it can get onto the body of whatever is going to pollinate it, or it needs to be elevated so it can get up in the wind so it can have wind pollination. Okay? So filament lifts it up, anther makes the pollen ultimately has to make it to the stigma where it's sticky, but my eggs are down here. So I got to get from here to here. What it does is it has enzymes that will digest this plant material, and it'll make a pollen tube. And then it'll produce sperm, and the sperm will make the little tiny leaf, and it will pollinate, or excuse me, it will fertilize that egg. The egg will become a seed. The fruit will begin to engorge. Probably, the most disgusting but fun titles you can get for a fruit is an engorged ovary. Fruits are, yeah, absolutely. Fruits are engorged ovaries. All right. You want me to show me any of this on like a video or animation or something? All right, let me do that. All right. Okay. Huh? All right. This is called a sepal. Right, these are called petals. Every part of a flower has a function, right? What's the purpose of a petal? Hmm?
Protect the flower?
Nah,
To catch pollen.
nope. That's what the stigma's for.
Make it look pretty?
Yes. To
For
who?
real?
The
Insects.
bee.
To the insects, not to you, but to the insects. Flowers, you know, the colors of flowers are there as a marker to bring in, whether it's a hummingbird or a bee or whatever, right? And some of these are, by the way, are incredibly, incredibly specific. They're attracting like one type of pollinator, okay? And so the colors of these are great. Sometimes you look at a flower and you're like, well, that's just dumb. It's just white, or it's just yellow. It's just lame. Because you can only see through the eyes that you can see. But there are colors on these in the ultraviolet range that you cannot see, which is really, really neat. Let me show you some of this, okay? Let's see, let me go back to this. Is to draw in, or at least the function, right, is to draw in pollinators, to show them where to go. Now, they're not coming to pollinate a plant. That's a byproduct. They're coming to get nectar, right? Bees, I guess, use pollen, but, you know, more often they're coming in to get nectar. The plant, it's a give and a take. The plant is producing some kind of a sugar that these insects need, and in return, they're going to go and cross-pollinate for them. So, the petal is there to attract. What do you guys said? To protect the flower. That's what the sepal's for, right? Well, this thing is developing, right? When it first comes up, it'll look like this, usually, something like that. All this is starting to grow and develop inside of the sepal. And then what happens is the sepal will split open, and this will mature, right? It'll unfurl, okay? There's a lot going on here for sexual reproduction to happen, right? You've got the male and female sex parts. You have beauty or color or scent or shape. Let me show you something else that's really cool.
This plant's not behaving like any